Let me tell you what a rational number is. It's a positive or negative whole number or zero on the top, and on the bottom it's a fraction. On the bottom it's a positive or negative whole number, but of course it's not zero because it can't be zero on the bottom. So a positive or negative whole number or zero on the top, and a positive or negative whole number but not zero on the bottom. That's called a rational number. Well, there's a word, we can say that quicker. There's a word called integer. Integer is a set of numbers that are positive or negative whole numbers or zeros. So I can restate this comment that I just made about rational numbers. They look like this. They're an integer on the top. See the list of integers? Any positive or negative whole number or zero is an integer. So a rational number is an integer on the top, and on the bottom it's a non-zero integer, anything possible but zero. Okay, that avoids that zero denominator dilemma. Okay, so let's look at some examples of rational numbers. -3/4. That fits the description. An integer on the top, a non-zero integer on the bottom. How about the number 0? Well, that can be written as 0/1. So yeah, that's an integer on the top, a non-zero integer on the bottom. How about 327? Is that a rational number? Yes, because it's an integer on the top, a whole number, and on the bottom it's a non-zero integer 1. Okay, so we're going to talk about rational roots or rational zeros as we call them. Remember what they are. You have to go back to that note that you've been sleeping with under your pillow to recall the importance of roots. Well, there are rational roots and there's irrational roots. And when you put them all into the same category, they form all the real roots, all the roots that are real numbers. See, real numbers can be divided into two categories, rational and irrational. We're going to concentrate on the rational roots. So here we see that every rational root of a polynomial, so what's that? That's a root that can be written as an integer over a non-zero integer. All right, so any rational root of a polynomial p of x, okay, where the polynomial has integer coefficients. In other words, no fraction or decimal coefficients going on here, no imaginary coefficients, just integer coefficients. Okay, we're going too fast. Every rational root of a polynomial with integer coefficients, the polynomial has integer coefficients, is of the form a factor of the constant coefficient of the polynomial divided by a factor of the lead coefficient of the polynomial. Remember, constant is a number at the end that has no x, and the lead is a number multiplying the highest power. We got to see an example. P of x is equal to 3x to the fourth minus 2x cubed plus 1/2 times x squared minus x plus 10. Okay, so what are the rational roots of this polynomial? Okay, now wait a minute. I would like to say this answer. Okay, I'd like to say the factors of 10 over factors of 3, but there's only one problem. This polynomial, remember, it was supposed to have only integer coefficients. Does this polynomial have only integer coefficients? Remember, integers are positive or negative whole numbers or zero. Look at it. No, no, no. We have a coefficient of 1/2. So this rule, which was going to work for us here, does not apply. I'm just going to move up this screen, do some crazy morphing, and get rid of that bottom part because that is not true. Had we had all integer coefficients on our polynomial, that would have been true, that the rational roots were factors of the back number, 10, and over factors of the lead coefficient 3. But in this case, it didn't work. So be careful, be on the lookout. We'll do some examples that do work now.